For decades, biologists struggled to predict how a simple string of amino acids folds into a functional three-dimensional protein. Artificial intelligence recently solved this mystery. Mapping the precise geometry of these structures in a matter of months. This data grid represents the scale of achievement. It tracks the physical coordinates of over 200 million proteins, effectively every biological structure known to science. Access to this library allows researchers to identify the exact mechanisms driving specific diseases, accelerating the creation of targeted cures and synthetic antivenoms. Biology has transitioned from an unpredictable mystery into a language we can write. We now treat cellular structures like programmable computer code. However, the effort to map every mechanism of disease provided us with the exact parameters required to dismantle them. These datasets exist as open-source files, reachable by anyone with a standard internet connection. Engineering complex biology no longer requires a massive research grant or a staff of specialists. The technical friction has been removed. The underlying mechanics of a synthetic cure and a synthetic pathogen are identical. The same prompt used to assemble a beneficial protein can be inverted to calculate a hostile, infectious payload. An individual operating from a laptop now commands the same structural design capabilities once reserved for multi-billion-dollar state-sponsored laboratories. By removing the barriers to scientific discovery, we stripped away the physical guardrails keeping catastrophic power in check. We have effectively published the instruction manual for our own destruction. This is the microscopic battlefield. Over millions of years, the human immune system evolved specialized cells to hunt, recognize, and destroy irregular biological shapes. But those defenses rely on physical recognition, which is where the principle of chirality becomes dangerous. Molecules can be built as perfect asymmetrical mirror images of each other, containing the same atoms but flipped on their axis. All natural life on Earth relies on molecules with a specific orientation. When a normal molecule enters a cellular receptor, it physically clicks into place, triggering a predictable reaction. If you build a pathogen using mirrored molecules, the physical geometry doesn't match our receptors. It drifts right past the immune system, completely unable to lock in, making it invisible to our defenses. The human body cannot detect what it cannot chemically touch. Mirror life functions as a biological zero-day exploit, rendering millions of years of evolutionary defense useless. Historically, engineering a stealth biological agent required massive physical infrastructure and decades of experimentation by highly trained specialists. Today, AI replaces the physical laboratory. Algorithms run millions of molecular simulations in the digital realm, refining thousands of variations in seconds. These AI models deliver actionable blueprints for stealth pathogens, providing step-by-step instructions directly to the user. The capacity to engineer a global pandemic has scaled horizontally. The power to end life is no longer held by hostile nations, but distributed to anyone with a laptop. We are now living and raising children in a world where an invisible, extinction-level threat could be compiling on a server in the house next door. There is a lingering dread in realizing that these digital recipes cannot be uninvented. Once a dataset this powerful is distributed, it cannot be deleted from the global consciousness. We have to ask, if total knowledge of our biology provides the exact tools needed to destroy it, is the unrestricted pursuit of that knowledge inherently suicidal? Our capacity for invention has outpaced our societal wisdom. We must prioritize a high-stakes gamble, where, given enough time and enough participants, failure is a mathematical certainty. The tech industry ethos of move fast and break things assumes the things being broken are replaceable. In species-level biology, the damage is permanent. Survival in this era requires a shift in how we govern technology. We must adopt the precautionary pivot. This matrix shows the core scientific precautionary principle. When an action carries even a 1% probability of a catastrophic downside, the gamble must be refused, regardless of the potential reward. We must prioritize survival over rapid technological progress. Humanity needs to leave the era of reckless innovation behind before the tools we build engineer our end.